Hey everyone, on this session I'm going to show you how to install a Jupyter-Lab. Jupyter-Lab is a Python package which allows you to just run Python on a browser. And I'm going to show you how to install it on Red Hat Enterprise Linux and how to run it on that operating system. You can run it on Windows, on Mac, or Linux. In this example that I'm going to demonstrate, I'm going to show you how to do it on a Linux platform. In particular, the OS version is Red Hat Enterprise Linux version 9. As you can see here, if I just say release a version of the operating system, you can see that I'm running Red Hat Enterprise Linux 9.1. And then also you can get that information from calling the etc Red Hat dash release file. That file also has the information saying that it is Red Hat Enterprise Linux version 9.1. Currently, if I clear my screen and I type in uname -a, I can also see that information. Linux operating system version is Enterprise Linux 9.1. And then the machine type, the architecture, everything is indicating there. So what I need to do is do a pep Python install packages and then a list. This will just give all the packages of Python that are currently the modules that are installed. And if I look at grep -i Jupyter to see what version of Jupyter is already installed on this machine, you can see that Jupyter-client is there, _client, _core, event, LSP server, and a number of them that are there. But what I'm going to do is install Jupyter-Lab here. So if I say which Jupyter, to find out if Jupyter is already installed, what is the binary file user bin, user local bin, and Jupyter is showing there, which is an ASCII Python script. So that is the Python script. And if I just do the same thing, and instead of doing a file on it, since it's a Jupyter there, I could do the -- version and see that all the Jupyter core packages that are showing. IPython is there, IPython kernel is there, IPython widgets are there. There's a number of them. So at this time, I'm going to use pep to install Jupyter-Lab. So what I need to do is clear my screen here, and I say pep install Jupyter Lab, one word, no space there. So this is going to install it right now. It just says Jupyter installed successfully Jupyter-Lab 4.0. So if I say which Jupyter now, you can see user local bin is still the same binary. However, I could just say pep list and grep -i Jupyter to see if Jupyter-Lab is also showing. Now you can see Jupyter-Lab is here showing us 4.0, the one that I just installed. So on the Jupyter-Lab, that module that is installed, I can also do a grep here -i Jupyter-Lab, one word. That way I just get the one that is start with the Jupyter-Lab followed by any string there, and the 4.0 is there. If I just want only to see Jupyter-Lab, the grep command is very helpful in that case. It just says that -w is a word separator. So Jupyter-Lab is there. Grep stands for global regular expression print. And there's another extended version with egrep that you can do multiple string. So at this time I installed Jupyter-Lab with pep install. I'm going to say Jupyter and then start it with using lab. But instead of doing that one, let's just do -- help. So you can see the syntax of Jupyter-Lab, that you can start it with a lot of these arguments. And one of the argument is saying dash dash version, which we showed you, the config dir and then data dir and all of that. So let's just run a few of those ones. And instead of this, I could say dash dash version. It will tell me all the versions are there. And then this dash dash help automatically give you that. Then you can just say config dash dir. Config dash dir is giving you the Jupyter configuration directory, and data dir is going to give you the data directory. Similarly, if you do the path, it shows you the path. So that is all the path. And if you say JSON, it's going to say you need the path. And when you just say dash dash path, it will just tell you the JSON information as well as the path of all the directories. So we know that all the configuration is good. We have it ready, and then I'm going to just say Jupyter space lab. That is telling you that go ahead, open a browser and start Jupyter-Lab on port 8888. By default, it is going to go to localhost port 888 and then /lab, and this is the interface that you see. That by default, this is a screen that comes in. It comes out with a notebook, a Python kernel, Python 3 kernel in this case, and the console window, and then the terminal window, the text file, the markdown, and then a Python file, and as well as the show contextual help, which is basically the help that you want. This interface, as you can see, is the background is white. You can go under the setting and then under the theme, and you can change it to a Jupyter-Lab dark, and the interface will change there. And if you're good with the white, you just leave it the light, and that would just do that. So at this time, you have a choice of whatever is pleasant for your eyes. You want to just keep that one. And then for me, both of them works either direction. It's both color is great for me. So I have no differences. Whichever one is pleasant for your eyes, you can choose that one. The language is by default English, and then there's other options here that you can, for example, change the terminal theme, or if you want a darker theme for the terminal, like here I could just say dark, and then if I just go here on the terminal, now the terminal is going to be a dark window with the white text. So uname -a, same thing, since it is a Red Hat machine, this would just say the operating system is Red Hat. And if you just want like a Red Hat command, like gnome terminal, it just opens a gnome terminals, host name, uname -a, calendar, date, whatever command you could just type in, it works. So if I exit out of this one, and if I just change the terminal again under the setting, terminal theme, make it light, then this becomes light. And then who, logged on, ID, pep command. So you notice that all the commands that you can do or run on the operating system, this terminal is allowing you to do this one. And if you're done with it, you say close this one, and now you can go back to this Python 3, which is the cell level. You can run even here commands like open up a gnome terminal. So by putting this bang or exclamation mark at the end, you can run any operating system command. If you just run it like this, it opens a cell there. And then if you just say, give me the calendar, okay, today is Saturday, and then that's the time. Exit out of this one and just run another cell, and then just do ls -l command line, and then you get a long listing. So notice that the list of commands that are there, you can use toBang also. toBang is saying that the output will show here. Notice for each output, it will just say that the last cell that you gave, the output will show here. So if you just do PWD here, print working directory, and it's going to show this. But if I just do that bang bang PWD or two exclamation, it just says the output of cell 5 is there. This is the difference between running two bang versus one. Two exclamation mark or one exclamation mark. The exclamation mark that is with two of them, if you say who, it just tells you the line number that you are. It is just says line 6, the output was this. But if I just run the same command with one bang and just say who, it's gonna just give me the output. It doesn't give me the cell output. And the nice thing about this one, you can just click on this bar here. It will minimize it, so you can just get the more to see on the screen. If the output is too much and you just don't want to see them, you can just kind of what is the word? You can shrink them, or you can just hide it for showing. Like this one is too much, so I could just say, well, just hide it. Now, I also have option of if I don't want to see these ones, I can just delete it and say, okay, I'm done with that one. Now a new cell comes in. So every cell that you delete, you have an option of adding here by putting a plus, and then here the delete. And then the up arrow and down arrow, all of that one is giving you option here. Also on the code level, you can select markdown, and then you can put markdown here. So for example, the number of items, say Jupyter-Lab is cool. So whatever you write this one, this would be with this markdown, it's just going to just show you like that. And if you want it with one text bigger than that, just say bigger text. So you can see for each of the size that you want, if you just do one bang, actually you have to mark it as markdown. You cannot just go, that was a common. So if you go here, you have to select markdown first, and then inside here you could say bigger cell, bigger text, and here, and then run it. Now you see that it's bigger. If you say markdown here, and then you say 5 of them or 4 of them, and then you say smaller text, and then you can just run it, and that would just be a smaller text here. So the markdown and the size of it is for editing. But if you run a Python command here, any Python command, say this is a simple common, then this one will be ignored by the interpreter. It will not run. However, if you say print, this is a simple test, and then you run it, it obviously it will put that one, or just do a print statement, 2 to the power of 5, that would be 32. That would just do 32 here. Similarly, if you just say, well, I want to do a calculation not using this power of, I want to use the pow function, you could say print to pow of 2 comma 5. And if pow is predefined on Python, then it will just do the same 32 here. But if you want to use the map function, you cannot just, you have to import it first. So you have to say import map as m, and then you say print m of pow of 2 to the power of 5. Now you're using the math module function pow, and you're getting the same 32. Since we imported m, now we can do a dir of m. You can see all the functions that are available for math modules here. And then, for example, if you just say, give me print, you could say print m of square root of 121, which is 11. 121, you will just get that one. And if you say, well, just let's get the square root of 10,000, that's 4 digits, so it should be 100. Square root of it, and it give you 100. So whatever math modules that you have done it, you can just use it. Similarly, you could say import OS module, and then os.system, and then run the OS command, like opening a terminal, let's say, or say gnome-terminal. So now you have opened a terminal, and then by doing this one, notice when I run this cell, it's just opens the terminal. Now I am on the Linux machine. I can run all the Linux command that I can think of, like cat edc os-release, clear a screen, man pwd. Any command that you could do is like just open out a gnome-calculator. You could run it and then open up the calculator and so on. Any command that you do is just allow you there. And if you decide to just say os.system, run the calculator here, you could say gnome-calculator, then it's going to open the calculator the same way that you did it from command line here. Similarly, if you just say one bang there, say gnome-calculator, this also open the terminal, the calculator. And then similarly, if you just say two bang and say, let's say gnome-font viewer, another font viewer, you could just open it and this font viewer shows up. So whether you do it with two lines, two bang or any other ones, the Jupyter-Lab is very helpful. So let's say I change the setting, now I go to a darker theme. If I go to darker theme and then just go here, say change, apply dark theme. Now I have the darker theme. And if I just run a similar command, now if I just close these ones, let's just close these ones and say I'm done with all of them. I just start from the top. Obviously, for each one of these ones, you can close it as well. So now I have this fresh screen here. I can type in also alias. Alias would give me a list of aliases that are here. And then notice that the list of aliases that allows you to do a lot of commands here. And so, like for example, ls command is already a less command, alias, it will run the ls command here. Similarly, if you just open a gnome terminal, and then just run that one, and then this one, ls command would do the same thing here. The only difference is there's here, the directories are the same, except one is blue color, here is a yellow color, or a greenish color. So the text, the data is the same. So if I say who command here, it's gonna just run who -r run level, and then any other command that I could think of, I could just run. It doesn't matter. But notice here, if I just run the who command here, it runs it for me. And if I just say who -r, give me this. And then if I just say, give me run level. So any Unix operating system that is allowed, or Linux operating system in this case, it will say that this is run level 5. But the thing is that here, let's say uptime. And then if I want to just do like a top command or something, I better use a GNOME terminal, because it's much easier for me to see it. So if I just open it here, I can say, and then I run top. And then any other command I could do. And then I exit out and I'm back here. Similarly, I can just go on to another tab here and just say open a terminal here. The terminal here, and then I can run top here. if I'm interested in htop, if I say which htop, let's say htop is installed, then I could just say htop. And then here, if I do a, let's say DNF list, it gave me all the packages that are installed on DNF. Similarly, like YAM list, YAM is symbolic link to DNF, and similarly, like RPM list, you can RPM list, and not dash dash RPM dash QA. QA is query all, and then you can just get every packages there. And if you're interested, for example, RPM QA grep minus I HTTPD, you could say, well, that's the package that I have. The version that is like HTTPD 2.4. If I want to get the last one, I could say tail -1, sorry, RPM, and then grep tail -1, and then it will give you that. And then if you say, give me a long listing of all the packages that are there, you could say RPM -Q L for long listing, and then put this one in backtick as the input going into the RPM-QL as the output, and you get those ones. And if you're looking for the binaries, you could say grep -I bin, and it will just see if there's any file that are on the binary that is there. It will just give you that. So grep -I HTTPD, and then all of those ones are there. So the options are very much there for you, or depending on what terminal you open or anything. And another option that is here, I mean, obviously you can run any modules and any commands here. Let me just show you some quick thing for Python. So for example, if I want to run like a list comprehension, and I create a list comprehension here. So I say list one, L1 is equal, and then I could say X for X and range of 100. If X module 2 is equal 0, and that means that give me all the even numbers. So instead of L1, I could say even. Now I just create a list of comprehension called even. And then if I say print even, here, this one should give me a list of even numbers, but there's a typo somewhere here. The even is mistyped, so I have to correct my typo, even like that. And because I define it even like that, so that's going to just correct it there. So the dir of even, if you look at this one, if I look at the type of even, it's gonna say it's a list. It's a list type. So if I just say print type of even, okay, sometimes when this happens, it is not seeing the cell that is actually, it is kind of hanging. So at this time, you need to do a kernel here, restart kernel. And then when you do restart kernel, this option comes back to you. And then later on, you can just run it. And it should give an output right away, but it is hanging right now. So we can do another one by just closing this cell here, say discard it. We don't care, we just open a new one and they say, let's say even, and then we say X even is equal X for X and range of, let's do 100 again, but this time we're going to say if X module 5 is equal 0. That means every number that is divisible by 5 and returns 0, that is the number that we are interested. So it's not even, it's we could say divisible by 5 or something, by 5. You could just say whatever string you want. So divisible by 5. That string does not make that much sense, but it's there. So d by f, and d by f. Let me just see. D by f not defined. X for x and range of 100 if x module. This looks like this cell did not run correctly. D by f. I think that's what the name I sound like calling this. Let me just call it something like x, and then we just print x. X is not defined. Somehow this cell, it did not run successfully. X for x and range of 100 if x modulo 5 is equal this. Let me just make sure that this cell runs. Somehow the whole thing is not getting it properly. So I'm gonna say shut down all kernels. And when this happens, you just have to start fresh with it, because somehow the kernel is choking right now. So the first thing you say, print dir of the CFL. It shows, yeah, the list of Pythons are there, the modules and everything are there. Now, if I just paste that line here and then just say print x, so the variable, now the kernel reads it, it's working. So even if I just say d by f and I just write that one, the string should work. It's not like what you name it, it just was that problem was the kernel was not executing this statement. So by shutting it down and returning it there, so we could do this one and we say if it's not equal, equal 0, meaning that whatever other numbers, you see 5, 10, 15, divisible by it, it was up to 95. It was printing, now we're looking for a different set of numbers that are not these. So it would be any number but these ones. So now we say, let's change this one to y, and then say print y. So notice that whether you create a tuple, list, data, dictionary, anything, you are welcome to just do using Python here. And Jupyter-Lab and IPython, everything is available for you. So in fact, if you go here and you say, okay, well, you just told me that Jupyter-Lab, when you install it, IPython is also available. So show me that one, which IPython, you can see which IPython, then it's available there, right? So if you look at this, which IPython, and you say IPython -- version, it is 8.12. So you can say IPython here, and it will just open up IPython here. Similarly here, you could say, for example, for item in, let's say range of 10 to 100 with a step of 5, just go ahead, print each item. You can just say, so we're gonna get 10, 15, 20, and with the range of increasing by 5. This is starting the number 10, and then increment by 5 up to 95. So we should get that one. When we are printing it, then I just press enter twice, and it's gonna go to 10, 14, and everything. So because I did it with increment of 4, if I just do the same thing and I go up here and just change this one by incrementing by 5, or maybe I increment by 10 just to get a shorter number, so you can get that. So there's different statement, different things. You can do if statement, for statement, tuple, while, everything on all of this. Here also you have the list of aliases. So if you want to say ls command, you can do it, or you can do ls like that, or ls like that. And then you can say pwd, and then uname -a, open a terminal, gnome -terminal, uh, gnome, not gnomer, I mistyped it, and then it goes there. And then open a calculator, whatever you want to do, calculator, it opens it for you. So the IPython is similarly available here. If you just run a command like, go ahead, show me a pep list, and it's gonna give you, do a grep -i request method or request modules there, and numpy here, numpy, if you just have the numpy version, it's installed also. And then if you just exit out of this one, if you're interested in learning NumPy or Python or for statement, if a statement, I have made a lot of other videos, but the objective of this course is, this session is basically to show you, once you install Jupyter-Lab, what you can do with it inside Jupyter-Lab. And then here you can see that I can go ahead, shut down the entire thing, or by logging out. You could just go file here and just say at the end, it says log out. I don't want to log out, I don't want to shut down, but when you do, you have that option. And you can save it, the name that you want to save it, or close the tabs that you have open. You have all of these options here. So this is the name that you want. If you right click here, you can just rename it, say, rename the lab, say demo1 Jupyter-Lab IPython. And notice that demo1, when you open it, this one, the whole instruction that you write with all the set of command, it gets saved with the extension of the Python notebook. And then NB is for notebook, I is for interactive Python. So if you go back here and open a terminal, and on the terminal, you say pwd ls-ltr. Notice that demo1.ipython is the name that I've saved it. So clear screen file demo1.ipython notebook. That file is a JSON file. So if you do a more on that one, demo1.ipython, you can see it's a JSON structure. And JSON stands for Java script object notation, which is basically a kind of array structure. It's like a data structure that is either an array or data dictionary or some kind of list, and then those variables or hash keys, and then some values for it, key pair values, data dictionary kind of things. So that is the demo1.ipython. But you also have an option of creating a Python program. So you can just say open up here. And then you can see also markdown and text files and other ones. You can play around with them. But let me just show you a Python script here. So if it just did not give it a title, you can just say, for example, rename this one to demo2.ipython. So when you do this one, and then inside here, you could say shebang, and then user ben env, and then Python 3. So you're saying that when the environment gets loaded, it loads the Python interpreter version 3. And then after that one, you can run any statement. So if I could say import, let's say numpy as np, and then say just print dir of numpy, just to test that one for you as a clear statement. So now I save this one. I'm going to go under file and save all, or save file, save Python file as. And so since I saved it as that name, I'm going to go back here, clear screen, ls-ltr, Notice that demo2.python is there. Now, cat minus n demo2.python, it will show the 5 lines that I have saved it there, right? So now ls minus ld demo2.python, it's a Python, but it does not have executable bed set. So even though the first line is saying that run Python, the only way I can run that one is say Python 3 and demo2.python. This will just give me the output there. But if I just want to run demo 2 like that, I need to change the permission, say change mode, u plus x, and then demo2.py. Now, if I just do this one, you can see that the executable bit u plus x, meaning the user could run executable. Every other person is not having write execute permission there. So the user has read, write, execute on the first three. The group has read and write, but other people only can read the content of it. Since I'm ID dash UN is Wahid and ID dash GN, my group is also Wahid, so I have full permission as the owner, read, write, execute, and read, write as group, but other people cannot execute it. So then I could just say demo2.py, and then I don't need to just run any other commands. So instead of doing just the dir, if I come back here and say, okay, let's make a comment this one, we just do one function as numpy, just we say, let's say, like array 1 is equal numpy dot array, and then we say array of let's say 1 comma 2 comma 3, and then just print that one as an array of 1 dimension, and then let's just make a 2 dimension so you can see the comma, and then we are going to say 4 5 6, those 3. So now we did this one, and if I say print array numpy, so A1 is already defined here. If I just do that one and save it, file save Python file, then I go back here and I just use the same command. Notice here, there's some typo this time. Does not match opening parentheses. So the one problem is that when I did this one arrow, I used the 2 dimension and I forgot to close the 2 dimension here. So when you do that one, now it is fixed, you have to save it again, save all or save Python file, and you come back here, run it, this time works. And then let's clear the screen and then just run it, it works. And then if you just say, well, that is good, but let's just do something more. Print numpy.info, and we just call A1. If we want to get more information on that numpy object, then you can just call the numpy.info method. And then that would print this, but I need to close it. So it will close that one. Again, save all files. Save all files, save all. And now I just go here and just run it again, and it's gonna give me more detail. So there's more choices, but again, I have about 6 different kind of tutorial for, or 6 or 7, just for NumPy. And I have it for Matplotlib and graph of sine and cosine. If you're interested to learn more on Jupyter-Lab or Jupyter IPython or Python idle, or let's say, what else? I think on the Python, I also have videos for Jupyter-Lab as well as NumPy, request modules, Matplot, OS modules, sys modules, and then PyCharm. A lot of those ones are there. So just look for those videos. We did discuss all of this, and let me just show you one more option here that you can have. So the text file, you can also open a text file and write your text. This is just a text file. So whatever you name it, you just click in here, say save it as, rename it my text file. It doesn't matter what you name it, you could just see it. And now clear the screen, ls minus LTR, cat minus n, my test file dot text, and you will see that is 0 byte. Let me see what I named it, my test file. So this one, we haven't saved it, I believe that's why. And when you save all, and then you just do that one. And let's see, now the size is 25 bytes, and it should be good. And you can see that one. And then when you want to add it, you can also add it with this one. So you could say echo, and this is a second line. You can just use double greater sign and then say my test file here. Now we just added to that end of that file. This is a test, and this is a second line. You could also just now, by refreshing this window on my test, let's see if this one is also gonna say somewhere, it should be like a refresh, but I can just open it again and just say file open as a text file. Open file from path, you can just say what is the text path. So the text path is already there, my test file.text, I think it was. Yeah, and you can see that the next line is added here. So you could do that one also here. Another way you could do is just on that text file from the command line, if you just run a command here, say man command, let's say printf command, you get this one, or clear screen man Python 3. So you get all the Python 3 here. If you want to send this one to an output file, say Python 3.man, you could just do that. More Python 3.man will just give you the same thing. So there's sending information from terminals to a file or text file. You have that option as well. So what else? There's the console here. You can open Python console, and by Python console, you're basically in the idle here, Python 3.9, as if you're just on a terminal. So if I'm going on terminal here, let me close this one here, and notice that when you go here on the terminal, you can also say Python -- version, and you say get me to Python 3.9. So Python will just drop you to 3.9. Here, every command that I run inside Jupyter-Lab, I could do the same thing. And for the sys module, there of sys, you could do. Let me just clear the screen here. os.import os.system, clear a screen, and then you could say print, let's say import sys first, sys.version. You will get the Python version that you have, sys.executable, give you the user bin. Python is the executable. Sys.platform is going to give you os.name is the operating system, POSIX version, and then you could say os.get env, and then env, and then you say, let's say give me the path. Here you could see that, or sys.path, sys.path will give you that, sys.version info. A lot of these are there, the methods that are there, like os.get current working directory, os.get login. So a lot of the information, os.get parent process ID, any method that you run, get process ID. And then if you just need the OS modules, there's all of them. So if you run a walker or any commands like process open, so if I just have a list here, clear screen, os.system, and then run the clear screen. Let's say I want to run more than one commands from the Python idle or console. So this console is the same as that. Right here, I could just say, let's create a list here. We say commands is equal, and then I'm going to run a couple of commands in the list. Let's say I want a command of gnome-terminal, one of them. The other one is host name. And then the other one is calendar command. And then the other one more command, let's say, just say df-h. So I have df-h also there. Now, if I just say print commands, this is just going to print the list of commands here, right? So if I say run cell there, it ran those commands saying that this was a list of commands. But now I say for CMD and commands, I want to just execute each commands. And then as I execute the command, I'm going to put it into a stream here. The stream is equal and say os.process pipe open, and then I'm going to open a command here. When you do open that command here, what do you want to do with it? So at this time, os.pipe open, and then open the command, then output is equal stream.read function. We're going to read the data output, send it to the output, and then print output. So if I run this cell, this command, CMD is going to be just one of these commands here from the command list, the commands that I have defined as a list. Then I'm going to just get each one of them, and it's going to execute each one of them. And then I get it. So now os.popen, it did not understand OS because I did not define the OS module. And so prior cell had it, but I did not define it here. So in order to do it here, you have to actually say import OS, and then just put these lines here. And then we're gonna just delete this cell, delete this one, but keep this one because we import this one. So by deleting this one, we don't have to worry about it at this time. Since I'm on this cell, I'm going to just say, go ahead, run this cell. And now that cell ran and opens it. And I can run the commands here, but I can exit out of this one to see my further commands output. So notice that the second command was basically gnome terminal hostname calendar df-h. So gnome terminal was open, then the host name was localhost, and the calendar was this month, and then df-h output there. So if I just cut and paste this one into a Python program here, so let's say I just say I like this one, it worked really good. I'm going to Control C this one. Let's see if I go on the terminal here. Obviously, I can just paste it here. If it works, that's great. But if it doesn't, get pasted there, I could just, this is frozen, so I'm going to close this one, close all of this, and then just open a tab here. This time I'm gonna just try to do a Python file here. And then if I paste this one, but I just need to put the Python interpreter, how user ben env Python 3 should be open for it, and then do this one. But notice that the CMD is not there, and port OS first, and then commands, I'm going to give it a list of commands here. So let's just make a PWD and then say run the command like grep, let's say get and password Wahid, and just that command, as well as ID-UN, as well as ID-GN. So you can run a few commands for the account, as well as a print working directory, those ones, just to look at it. And then, and instead of print WD, let's just make more commands here. I'm gonna just add uptime, and then free-h, the memory and other information, I could get it there as well. So just, that's good enough for this list. And then so if I save this one, save Python file as say demo3.python. Now I'm going to go to the console here. If I want to run it here, obviously I could run the Python script, but I rather open a terminal to look at the content of the file and permission and everything. So now ls-l3 demo3 is there. ls-l-d demo3.py is there. So if I just say and run it like this, demo3.py, it's not going to run because the permissions are not set. But if I say change mode 755 and demo3.py, now I just change the permission to be executable, then I can run it like that. And as you can see that it gives you the command for each one of them, demo3 and then other ones. So vim, at this time I'm on inside here, I could do vim demo3.py, and I just could change, say, for each command that as I run, I could just say print the output of the command cmd is, and then we could just say after that one is the output, right? But in order to do this one, since I used that f string, and now I can just use that variable cmd in the braces. Now I can just do this. Now, since I'm on VI, I could set line number, and you can see on line number 6, I added that line. So if I say W key, write and quit, it will quit it, and then now cat -n demo3.py, you will see that the new lines are there. And if I just run the same code like last time, now it says for each command that it runs, it says the output of ID-UN is there. But notice that I need to just put each command within a single code. So, and this is how you do it. You go vim again, and then inside here, you just use a single code here. Because we use double code here, then inside you cannot use double code again. Otherwise, you have to skip it. So now clear the screen here, cat the command here. You can see that it has this. And if I run it for this executable, the output of the command get password this is showing here. And notice that the commands is within the single code this time. So we demonstrated a lot of stuff with Python as quickly as I could. I hope you learn a lot of stuff, and it is easy. It is just don't be afraid of running an application or programming language. If you're a programmer, a developer, these things are gonna get easier. The more you work on it, the more it gets easy. Work on it on different platform, it is just the same. So if I'm on a Windows platform, CMD here, I open a Windows platform. Notice that I'm on a PowerShell command, or actually I open a command prompt here. And then I can get into PowerShell by just typing in here, and then I could do Control plus and then run commands here. So Python 3 -- version will tell me the same thing on the command prompt of PowerShell or Python version. So Python 3 would be the same thing here, -- version. And then if I just say Jupyter-Lab, this is going to open on the Windows side, port 880, 8080. That is my Windows operating system. Notice on the command prompt here, if I just open another terminal here, now I'm on a PowerShell terminal. And if I just do a plus here, that system info, 5 more, it is still showing you that you're running Windows 11 Pro version. And then since I open on this tab, Jupyter-Lab, that means I am on the Jupyter-Lab on here. So if I just go on the browser here, and then on this browser, Jupyter-Lab, notice that I have a set of other commands that I have demoed before with Python 3. If I just kill this one and just say open the new one, I could just say there. Notice that I'm on a Windows operating system now. So the commands that over there, I was doing aliases, you would see commands that were related to Linux, and here's commands that are related to the Windows operating system. Like host name is going to show algorithm. And if I just say run the system info, do a find string /i, and then say OS name, give me the OS name. Notice that this is gonna just run the command, and it's gonna just give you the operating system Microsoft version this. But Jupyter-Lab is very powerful. Whether you're working on Mac or Linux or Unix, it's agnostic. As long as you just do the right command, like for example, import OS. Notice once I do OS, at this time, if I say os.system and then say just run the command inside the os.system, I want to run the command, let's say 3 on C colon demo directory, and just and that is good enough. So if I just run this command there, and it says that it's successful, it returns 0, meaning that this command ran, but the output is not showing. So in order for me to do the output here, I could say like string is equal, and then os.process open or pipe open, and then say 3 C colon and demo, I believe that's demo directory. I could be wrong on the directory, but it doesn't matter. I could say output is equal, and then again stream.read function, and then print output. Since the other command succeeded, I did not see the output, but let's see if this one print output. Yeah, this one prints output right away. And you can see that that is just telling you, but you don't see the 0 because the system function call was saying that it is succeeded. That was a successful command, but it is not there. So if I just change this one to demo slash, let's say, programs, I don't know if I have a programs directory in there. If I do, it will just go there. Yeah. And then if I just have a Python under that one, Python, then it will just go list the directory there. And if I just say, give me a tree directory with /f for files and then /a for ASCII, then you will get the files as well here. So all the Pythons are there. Okay. And then at the same time, if you just say, let's just do system info, and instead of getting this command, give me the memory, just say how much memory you have. You could run that one, and then it opens up the memory information, as you can see here. Or just say a model for the processor's size and speed and everything. So when you run this one, it says that you have a Intel 64 family with this 3.14 gigahertz. So that these commands are a lot of them you can run. So instead of the system information, if I want to just run a command like just to get to control panel. Let's see if that would opens up a control panel. No, it does not. But it will open up a command prompt if you just say CMD and CMD or the command prompt. It is going to just do it. Since it's inside the Jupyter-Lab, it does not understand it as well as it does it from here. So here, if you just type in CMD, it opens the command prompt. But inside the Python idle, you could do this one. So if I'm just here, say Python 3, and then say import OS, and then os.system, and then just say CMD. Let's see if that works. Yeah, it runs the system directory. Now I'm inside there. And then once I exit out, I'm back in Python. So if I just say run the version command, you could do the same thing here. So inside the IPython. A lot of these commands are very helpful. Like if you just get the entire help here, you could run it there and just get the output. Similarly, if you want to get to PowerShell, but I don't want to demo so much on this. I'm going to exit out of this. And then here you could just say, for example, some other commands like what other commands on Windows you could do. Like, for example, let's do the percentage here. Percentage ls magic, list of magic that what are available for you. So you have percentage list magic. Let me just close these ones. I'm going to close all of this. I don't need it. And right here, I say percentage ls magic. ls magic. So this one is similar. The other one that does not right now response, because if I say percentage dir, yeah, none of the command works. So you have to restart the kernel here. Restart kernel, and then we can close all of the, shut down the kernel, and then restart it. So discard, and then just here and say percentage ls magic. Line magic function, ls magic not found. So magic like that. That gives you line function as well as cell magic. So with all the line magic commands, like you can do percentage, any of these commands. And then with the cell magic, double percentage, and then the command. Sometimes you could be on a Linux machine, you could get into bash, and like here, bash is not available because of Windows, but Python, Python 3, and everything else is available here. So the percentage pep, for example, would just say that is available. Pep list this would just run the list command here and return the PEP here. But if you're on Jupyter-Lab, which I'm going to come back on Red Hat machine, and then inside, let's close these ones, we don't need it. Inside, I don't need this one, and then I just open this, and right here I could say percentage PWD is the same thing as I run #/PWD or double bang bang PWD. That is going to show me the same output. However, if I just say here with percentage PEP list, this is basically running the list on the, and you have to just put no space between the percentage and the other one. Otherwise, it's gonna give you a syntax error. So when you do that on PEP list, it gives you all that. Okay, I have covered enough. I think you're good enough to just work with Jupyter-Lab either on Red Hat Linux or Ubuntu Linux or any other operating system, Mac, Windows. It is the portability is there, so you just have to look at it. For example, here, if I just say os.name, if I had already, let's say import first OS, I could say, for example, print os.name. Notice that if I just have this one, that means that OS is already imported. So since it was not imported on this cell, I'm going to have to import it first, then I run it. Now it says POSIX. POSIX meaning that this is the same as Linux and Mac. But on a Windows operating system, if I just go here and say Python 3, and then I say import OS, and then os.name is going to say int. So os.system, the command is clear screen, will clear my screen, and on the Linux machine is clear command. Because whatever command you do it on the terminal, and then that's the same command. So on the terminal, when you open a command here, you're saying clear. If you do a -l and you want to clear your screen, you say clear. But if you're inside Python 3, you say os import os.name, it's POSIX, and os.system, and then if you want to clear your screen, you just run the clear command, not clear screen, clear command, because that's a Linux and Mac clear command. Okay, so I hope you learned enough. Thanks for watching, and please make sure to go to our YouTube channel and subscribe. This is my Web University free education videos, where I bring you a lot of computer science related subjects, whether it's operating systems such as Linux, Unix, Mac, Solaris, Windows, any operating system, Red Hat, Ubuntu, CentOS, Rocky version, there's a number of them. And then programming languages such as C, C++, Python, and other shell scripting and a lot of stuff. Excuse me. So just enjoy watching it, and then make some good comments so I can improve it based on your needs. And take care. Bye-bye.